Good day. Usually found Thursday in the afternoon I posted the data that you'll need for the lab. And so one generous group provided this data. So we had to know the pressure in the room, the temperature in the room. They happen to use 5.05 centimeters of magnesium, and they're going to use that with the fact that it's 1.38 grams per meter for the magnesium. It comes in ribbon. And if I cut a 5 centimeter piece of magnesium, it's barely going to weigh anything on the scale, so I won't have many sig figs. So by using this unitary rate, I can calculate the mass. Yes, you have to do a bit of thinking there. They measured the volume as 69.2 milliliters, and that's going to allow us to get at the actual yield of the hydrogen gas produced in the lab. Square brackets means concentration, so the concentration of HCl was 6.00 molar. So you should have that already from yesterday. You should have this sheet in your package, and I think there's 2 sheets. And obviously it says experiment 7B goes through, and somewhere one of our students said, hey, we need a purpose. So there's the purpose for the lab if you want it in one sentence, otherwise you copy out the objectives in the lab report. But basically we're going after everything. Limiting reactant, excess reactant, actual yield, theoretical yield, percent yield. And we're basing it on a lab reaction that gave us a gas. So there we is. All right, so yep, we need a proper lab report. Data and observations. Well, I've shown you what I want for the data and observations. I need a labeled diagram of the setup. You can steal that out of the lab manual, except instead of a tube, you are going to put in an upside down graduated cylinder with a cage of magnesium and a 1-hole stopper at the bottom. So you're going to give me the balanced chemical equation for the reaction. You'll give me the states. The lab may help you with that. And once you have your data table up here, now you're going to figure out the mass of magnesium, which you get to moles. You have a volume and a concentration of HCl, so you can get your moles. And from those 2 sets of moles, you're going to show which one's limiting and which one's excess. And you're going to tell me the amount of the excess. So it says, hey, if it's magnesium, I need the excess mass. And if it's HCl, I need the excess volume. Now, things get trickier. You've got to come up with theoretical yield by mass. You have to come up with an actual yield by mass. Those are 2 tougher ones. Once you have those things, no sweat to get the percent yield. So right here, it's telling you, follow these steps to get the actual yield of hydrogen gas. So it says determine the volume of gas collected. Incredibly, that's in your data. Then you have to determine the vapor pressure from page 87. So let's see if we can find page 87 in the lab manual. Aha. And so what is this saying? Well, it's saying that our volume of gas is not just due to hydrogen. There's going to be water vapor because we collected above water. And our temperature, I believe, somewhere we had the data. Did I get rid of that? 20.3. So we're going to consider that to be 20 degrees. Where'd you go? There we are. And at 20 degrees, it's 2.34 kilopascals. So that means we've got to take this pressure here and subtract 2.34 kilopascals from it. And that will tell us the the pressure due to just the hydrogen. So we've got our pressure that we'll put in, we've just calculated. We've got a volume, it's got to be in liters. We're going to multiply those together. We're going to put this 8.31 with the crazy units. Not too worried about the units for that thing, it just goes right there. And we have to convert our temperature from Celsius into Kelvin, and it tells you how to do that. And it goes right there. So you know pressure times volume, divide by this 8.31, divide by our temperature in Kelvin. That gives us the number of moles of hydrogen. And once we have that, we convert it to mass, and we have our actual yield by mass. The theoretical yield should be easier. And let's see if it asks you for that somewhere here. Oh yeah, so theoretical yield, of course, you're going to have to figure out which is limiting, which is excess, and you're going to go traveling over, get your moles of hydrogen gas, and get your mass. Now what we really hope is that your theoretical yield is larger than your actual yield. If it's not, a couple of sources of error can help explain that, but it's a lot tidier if it isn't. Then it asks you questions about the procedure, and for you, you might find that a little bit harder because you didn't do the lab, so that means you better read the pre- and post-lab discussion, and hopefully I'll give you some clues. Number 2, difficult part of carrying out this experiment? Well, I guess not being in the classroom might be something that's more of an opinion question. Number 3 is really asking you, do you understand what it means when we talk about limiting and excess reactants? And do you understand what can happen to the amount of product we have when we change the amount of reactants? So you're going to go through there and apply a bit of logic. Then we have a little more practice stoich, and you're going to go rattling through this. And you better show your work nice and neatly spread out, easy for me to follow. Some fantastic sig figs. You're going to give me at least 5 sources of error. And of course, you have to state how they would affect the actual yield of hydrogen. Your conclusion can be one sentence in which you tell me about the actual yield, theoretical yield, and percent yield. Like I say, I've done my best to make it clear with you having not seen the lab or done the lab. But that doesn't mean you can't ask me questions. You certainly can ask questions, and I'll sort of decide how I'm going to help you. So good luck with this, and that's where that lab sits. And yes, it is almost as crazy as the finding the size of a molecule lab.